today we are going to start the next topics, that is project management. Basically, whenever you are having a project, a large project, it may be related to construction, it may be related to R&D. A large project is there, how to complete the project or how to handle the project, that we want to discuss in today's class. Different mechanisms are available, methods are available for optimizing the projects. Let us see what is a project. A project is a temporary task in hand involving a connected sequence of activities and range of resources, which are designed to achieve a specific and unique outcome and operates under some constraints regarding time, cost, quality, resources or manpower, etc. That is, you have a sequence of connected activities are there, and for that you are having a resources, a set of resources. Using the resources, we have to design the task in such a way that we have to achieve a goal, and for that we have certain constraints. As we have told, the constraints may be regarding time, it may be regarding cost, it may be regarding quality, or it may be regarding resource or manpower. The next is, what are the characteristics of a project? So, basically when we are talking about the project, that is, you want to handle a situation where you have to solve or you have to perform a task for which you are having a particular goal, and to achieve the goal you have to perform either sequentially the activities, or sometimes the activities may have to be performed parallelly also, and the constraints are there. Now, let us see the main characteristics of the projects. The number one is unique one time operational activity or effort. That means, the initially what you are telling, operationally you have to do it, the each activity or effort has to be performed only once, and the activities are unique in nature. Please note this one, the activities are unique in nature. Number two is requires the completion of large number of interrelated activities. That is, you have some activities, the activities are interrelated and you have to complete those interrelated activities. And so, interrelated activities means, I want to say that if you cannot complete one activity, you cannot proceed to the next activity. Just like whenever you are constructing a material, maybe first you will design it, then you will think about the materials, then you may think about the manpower, something like that way. Number three is the resources are limited. It is not that you have unlimited resources. Resources means it may be in terms of manpower, it may be in terms of capital, it may be in terms of investment, anything. So, we have to understand that the resources are limited, and to complete one activity there are certain budgetary amount is available. The time, it may be in terms of time, it may be in terms of money. Number four is completion of each activity combined to establish a pre-specified objective. That is, whenever you are completing one activity, then you are basically you are getting some objective was there, and that objective has to be fulfilled. So, we are having the predefined objectives, and whenever I am completing one activity, the objective has to be performed, the objective has to be fulfilled. The examples of projects, as I was telling, it may be construction of house, factories, bridge, etc. Or number two, it may be you want to in terms of R&D, developing new ships or the military weapons. Number three, it may be laying the oil pipelines. Then the planning of organizing some games, just like your Olympic games or World Cup football, World Cup cricket, like this. Similarly, the organization of the concerts, selling or purchasing of items via several links. Via several links means manufacturer are purchasing or producing a particular item. From the manufacturer, it is going to the distributor. From distributor, it is coming to the wholesaler. From wholesaler, it is going to the retailer. From retailer, again it is coming back to the customer. So, different forms are available, and by this way I have to, in the project you are having different subsections and I have to complete this subsection. So, basically we are interested whenever a project is given to us, how to complete the different activities of the projects either sequentially or parallelly to achieve the predefined goals. The next one is, what is project management? The project management, we say that it is the application of allocation of tools and techniques to direct use of diverse resources towards achieving a predefined goal within time, cost, quality constraint. So, please note this one, that I have the tools, I have the techniques, I have different resources are available. So, I want to allocate the tools, that I want to use the techniques and I want to use the resources available, and for this, by this what I want to achieve? I want to achieve some predefined goal. Now, whenever you want to achieve some goal, some constraints are there. The constraints may be the time, it may be cost, it may be the quality. Time means I have to build a bridge say within 6 months. So, my constraint is this one, or sometimes it may happen that I have to complete a project within 1 crore rupees. So, that is my constraints, or sometimes money does not matter, but the quality matters. Just like for the R&D wing, whenever you are developing some weapon, what is the accuracy of the weapon, it matters, not that how much money is required or how much time it takes, it matters. So, the objective, I have to achieve some goal, and for achieving the goal different kind of constraints are there depending upon what kind of projects you are handling. Next is the task breakdown structure. Whenever you are having the project, I have to break down the task. So, number 1, we are telling that a method of breaking down a project into several parts in a hierarchical structure. Now, several parts means I want to say it may be component, it may be subcomponent, it may be activity, it may be task. Or in other sense, broadly if I say, I have to say that you have a large problem or the project, you subdivide the problem, that is you break the problem into some divisions, and if required you again break those subdivisions. Like this way you break into smaller problems, that is you are having the large problem and the large problem is being subdivided into very smaller problems, and you can handle those smaller problems either sequentially or parallelly, and ultimately from hierarchically you have broken it. So, hierarchically from down if you go up, then you will reach at the top, that is you will achieve the goal. So, this we call as the task breakdown structure. The next point is, such tasks as I was telling can be completed independently with respect to other tasks, facilitating the resource allocation assignment of responsibilities and measurement and control of the projects. That is, it may happen that some tasks can be completed independently without bothering about whether other tasks has been completed or not. And sometimes you will find that there are some tasks which cannot be completed unless you have done, which cannot be taken up unless you have taken or some other earlier tasks or predecessor tasks has been already completed. So, whenever you are breaking the project into some tasks or activities, there are two type of activities then it may be there. One is that you can parallelly run some activities or perform some activities, and there will be certain activities which cannot be performed until some earlier or previously defined activities has been completed. This is point number 2. And point number 3 is, there are certain constraints like due date, late penalties, early completion, incentive, budget, etc. Whenever you are taking up a project, always there must have a due date. I have to complete it by this date. If I cannot complete it, nowadays always there will be penalty clause is there. If you cannot complete it by 6 months, if it is delayed by another 1 month, say there will be a penalty of 1 lakh rupees, something like that. And similarly, there may have early completion incentive. In place of 6 months, if I can complete a job or project within say 5.5 months, I will get an extra amount of 2% or 3%. These are early completion incentives. and similarly we have the budgets, budgetary constraints are always available. The many large projects in the field of computer system, construction, fabrication, supply chain management, R&D, that is research and development, are planned and scheduled in the form of network. So, now we are using a new term that we are calling as network. As I have written, different fields I have written. In fields of computer science or in the construction or in the fabrication, supply chain, R&D, whenever you are having the project basically you are drawing in some form, and that form you are telling as network. That is, different activities or tasks you are subdividing. As I was telling, a project is there, the project has to be subdivided. So, once you are subdividing the project and you are getting different activities, now the activities paths can be shown through some diagram, through some graph, which we are calling as network, or in other sense the project can be transformed in terms of retranslated in terms of some network. The next is so we have to basically study the network problem, and here we want to discuss the methods to identify the trouble spots of the network problem, and then we have to minimize it by finding the critical factor and coordinating the various parts of critical job. Basically, we are telling now we are having some trouble spots in the network problem. What are the trouble spots? The trouble spots can be the production bottleneck, it may be delay, it may be interruption, it may be breakdown, something like this. So, I have told you production bottleneck, that is you want to produce something, for this reason, that reason I cannot produce it. Similarly, I wanted to produce some item by 1 month, but it got delayed, maybe due to labor problem, due to shortage of labor, or due to unrest, something like this. Similarly, different kind of interruptions can also occur, and the last one is always machine can break down or the natural calamity may be there. So, for these reasons always we have to take care of these problems which we call as the trouble spot, and from the trouble spot we have to identify the trouble spot or take care of the trouble spot, and then we have to minimize the critical factors and we have to find out the solution of the problem. Now, as I was telling you that the problem can be, or the project can be drawn in terms of some network, and from the network basically we want to find out the solution. There are two basic methods for planning and control of network problems. As I was telling you, if you see, one we call it as the critical path method, or in short we call it CPM, other one is the program evaluation and review technique, that is PART. You see this one, two different techniques are there, one we are calling as critical path method, in short afterwards I will call it as CPM, and other one is PART, that is program evaluation and review technique. These are the two basic techniques which are used to solve the project management and, or in other sense, to solve the network problem. Basically, that if you see, they differ in one way, that is CPM considers deterministic activity duration, whereas PART considers the probabilistic activity duration. Now, you may ask what do you mean by probabilistic or what do you mean by deterministic, and why we are differentiating. There may have some problems or some projects where I know to complete a project how much time is required or how much money is required, which is known to us, which is predefined and whose value is constant. Say it will take 3 months, it will take 6 months, something like that. So, the problems which are having the deterministic or known values, those problems are solved by the CPM, that is the critical path method. Whereas, whenever you are trying to develop as a missile, when you are trying to develop a missile, you cannot tell the time range that I will complete it by say 1 year. It may take 1 year, it may take 8 months, it may take 1 year 2 months, that is 14 months. So, by certainty you cannot say how much time it will take to complete one activity. To handle this type of situation, by observing the previous data, we can say that my activity or the activity time or cost will follow some distribution, and then we have to handle the activity as the we have to take the activity as the probabilistic distribution. So, whenever in a problem, network problem or the project problem, project management problem, when your activities are taking the probabilistic values, not the deterministic values, then we solve those type of problems using the PERT method, that is program evaluation and review technique method. What are the basic differences between PERT and CPM? Let us see this one. The basic differences, as number 1 is it takes deterministic task time, number 2 the PERT takes probabilistic task time. The activity on node network, that is whatever activity you are doing, that is on node network, whereas activity are performed on the arrow network. The difference will be clear whenever we are handling the problems of CPM and PERT respectively. Now, CPM is used for repetitive jobs, whereas for non-repetitive jobs we use usually PERT. That is, for repetitive job means I want to say that some problems which can be repeated, some activities which can be repeated, for those kind of problems we use CPM, whereas in R&D usually the problems are unique, they cannot be clubbed with the earlier defined problems. So, they are not non-repetitive jobs, therefore, those problems are solved by the PERT method. Now, come to the network. Let us see, first we will go through the network, how to draw from a project, how to draw the corresponding network, then we will see how CPM works, then we will see how PERT works. This is our basic idea. So, what is a network? A network, we say that it is consists of a set of nodes connected by arcs or branches. That is, if you tell, if it is something like this, if I draw something like this, I may say this is a node, this is another node, and you are drawing this, it may be connected by some arc. So, as I was telling you, the network is consisting of a set of nodes connected by some arcs or connected by some branches. The next one is, we say it is a graphical representation of project's operation. Graphical representation of project's operation, that is, as the project flows, graphically you are representing it, and it is composed of activities and events that must be completed to reach the end of the end objective of the project. So, basically now we are telling that in the graphical representation there will be activities, there will be events, and those activities and events has to be completed to achieve our desired goal. So, if you can say something like this way, I have drawn this, from here I may go something like this, and from here I am achieving this one. So, it may be something like this. So, this is my starting position, this is my goal, that is, this is my ending position. So, different activities are there, you are drawing the flows, and the activities has to be completed in time. Just like if you see this activity, unless this activity is completed, I cannot start neither this activity nor this activity. So, whenever you are graphically representing your problem, that we are calling as network. So, basically what it happens, I can say that your network is nothing but is a planning of sequence of completion of each activity. Planning of sequence of completion of each activity, and to get and what is the relationship among them. That is, if you see from here, these are the different activities. Once I am completing this activity, I am going over here. So, I am planning that the sequence in which different activities will be completed, so that I can achieve my goal. So, my next point is, now what is an event? If you see, event represents the beginning or completion of some activity, and as such it consumes no time and resources. So, basically what I am telling, beginning of completion, what is an event? I want to do something, I want to make a soil test. So, this is an event. So, For event, this event has to start, has to end. For any event, it does not associate any time or any cost. But for the activity, that is for soil testing, this is an activity. For this activity, you require some time, you require some money. So, it is also known as, if you see, we also call it as a node, and an event is not complete until all activities following into it are completed. That is, whatever activities before that is there, if that is not completed, we say that the activity will not be completed. Just like if you take this one, it will be completed only before this initial and this activity is being completed. And so, in a network diagram, as I am showing you, usually the activity or the event is represented sometimes by circle, as I have shown here. It may be by a rectangle, it may be by a hexagon, or it may be by some other shape. Let us see this one, as I have written at last. It is represented as, in a network diagram, it is represented as by a circle, rectangle, hexagon, or by some other spaces. Now, the activity, as I have showing you, I am formally now we are defining activities are denoted by the ordered pair of numbers of their starting, it may be tail, it may be initial event, and there will be one ending event. So, basically there is one starting event and there is one ending event, and an arrow I to j, if you see the figure, in the figure I to j extends between two events, where we tell that the initial event or the tail event is I, which marks the beginning of the activity, and j is the head event. So, please, and that is the terminating event. So, in our figure, if you see this one, in this is the starting event, this is the ending event, whereas this the initial event, this we call as the tail, and this we call as the head, and arrows are there. Depending upon the arrow, you are deciding which one is the tail or which one is the head. So, depending on this arrow, you are telling this is the tail, this is the head. Now, different type of activities are available, you see in the PPT. These are predecessor activity, successor activity, dummy activity. Now, what is predecessor activity? Predecessor activity are those which must be completed before one or more other activities start, or before, whenever you are starting one activity. If you see, before you starting one activity, before that if some activities are there, those activities must be completed. Or in other sense, in this figure here, if you see, if I think about this activity, the predecessor activity of these are this one and this one. So, these two are the predecessor activity of this, that is, which must be completed before one or this activity starts. So, before this starts, these activities has to be completed, and these activities are known as the predecessor activities. Similarly, your successor activities are those which must start immediately. Successor activities are those which must start immediately after one or more of other activities are completed. That is, in the figure, if you see, the successor activity of this one will be this activity, because this must start after this. So, once I am completing this, after this activity, whatever activities are there, those are successor activities basically, and whatever activities are there before this activity, this we are calling as the predecessor activities. And there is one more type of activity which we call as the dummy activity. Dummy activity is an activity which does not consume any time or resource. It is denoted by dotted line. So, you may ask that once you are telling that the dummy activity is the activity which does not consume any time or resource. So, why it is required? There must have some reason for which it is dummy activity is required. This we have written here. Application of dummy activity must be considered when two or more parallel activities have same head and tail events. Two or more parallel activities have same head and tail events. And number 2 is two or more activities have same of their immediate predecessor activity in common. That is, the dummy activity represents the given precedence relationship among the relations. It is something like this. If you see, if you draw a figure, you have something like this. From here you have drawn this, you have drawn this one. From here you are going to this, say from here you are coming to this side, and from here you are coming to this. Usually if you see, the arrows are something like this. So, this is your starting activity and this is your ending activity. So, this is your goal. In general, in a network problem, what happens whenever your activity is there, it must have predecessor and it must have successor, unless it is the terminating node or terminating activity. If you see this one, this is has predecessor, but it has no successor. So, basically after this it has nothing, no activity has to be performed. In this case, to complete the problem, which I will discuss afterwards again, we draw some line, some activity like this. A dotted line is being drawn like this, so that it can show that from here it is basically going to the end node, and this we call as the dummy activity, just to complete the graph, that it must have predecessor and it must have successor, and for this reason we call it as the dummy activity, which does not require any cost or time. The next one is logical sequencing. There are some activities of each project which can begin only after certain other activities has been completed. As I was telling, the activities can start only when some other activities has been completed. In a network schedule, such relationships are called constraints, and we represent it by the inequality A less than B. If you have written, I have written here A is less than B. What is the meaning of A less than B? That means A should be completed before B, before the beginning of the activity B. That is, A should be completed before the beginning of the activity B. So, please note this one. If you see, for an example, we have 4 activities A, B, C and D. The project of construction, A is sketching of the structure, B is collection of the material, C is collection of workers or human resource, D is the division of work among workers. Now, these are the different activities I have to perform, A, B, C and D. A is the sketching of structure, B is the collection of materials, C is collection of workers or human resource, and D is the division of work among workers. So, if you see, unless I am completing the activity sketching of structure, I do not know how much material is required. Again, unless material is collected, I cannot work with the, or I cannot find out the workers or human resource who will work basically, and then which people will work, which kind of thing, that I cannot divide. So, that is the reason the inequality can be here A less than B less than C less than D. The meaning is that the sketching of structure has to be completed, and once the sketching of structure is completed, then only I can go for the activity collection of material, and once the collection of material is completed, then only I can go for the next activity, that is collection of workers or human resource, and then I can go for division of work among workers. So, if you see, you have the project of construction of a building. I divided into 4 activities, and here I have seen that the activities has to be performed sequentially. What is the sequence? A, B, C and D, that is A less than B less than C less than D. You may find some activities which can be performed parallelly, that is, in one one housing project, maybe you are building parallelly 10 houses. So, what you can do? You can draw the structure, then construction of material, collection of material, whenever you are doing, you can collect it at a time, and when I am building the houses basically, then I can build it parallelly. So, I want to say there will be some activities which has to be performed sequentially, there are some activities which can be performed the parallelly. So, any project can be divided into several activities, and the activities can be grouped, whether they can be performed sequentially, whether they can be performed parallelly, and what is the sequence, that is which activity has to be performed first, or which activity should be performed when this activity has been completed, or like that. So, this we call as the logical sequencing. Now, in logical sequencing process, three type of errors may occur. What are the errors? If you see here, one is looping, another one is dangling, another one is redundancy. So, what is looping? As you know, looping is it is also known as the cycling, that is looping we call it also as cycling. It occurs when an activity is represented as going back in time, and thus a closed loop of nodes are formed. From the figure, I think it is not clear, but you may see from here, from this one, you have an activity A say over here. From here you are going to the activity B. From B you are performing another activity say C. From C it may be on this side, and sorry, not this C, and from here you are performing another activity say D. So, basically if you see, it is forming some cycle like this. So, whenever you are having some approach something like this, then we call it as the looping. And so, whenever what kind of errors I am telling, that whenever you are drawing the network, then a looping can occur, the looping looks like this. So, if you have the loop, then you cannot, you have to come out from the loop, otherwise you cannot complete the project, it is quite obvious, you cannot go to the other sides. So, how I can break the loop, that we have written, it can be avoided by checking the precedence relationship, that is precedence relationship of activity and numbering them in logical order. That is, depending on the precedence, you can say from here that this is completing this, and I can break any one of them. This again we will see afterwards. Then the next one is, if you see, dangling. In a network, it is required that no activity should end without beginning being joined to end events. Please note this one. In a network, if it is required that no activity should end without being joined to end events. I showed in basically in the last slide. If this condition is violated, we say that the dangling occurs. And number 2 is, there exists an activity other than final activity which does not has any successor. So, basically there are 2 points. First point, we are saying that there is no activity should end without being joined to the end event. There must have the starting and end event. So, it must join to the end event. And number 2 is, each and every activity must have some successor. So, if you see, you are having something like this, say this is activity A, from here you are doing something like B, and from here you are going to say this is E, this is say C, this is from here to here say F, and there is another one that is say D. You have a network like this. In this network, this is the starting network, this is the ending network. If you see properly, then you will find that this particular D is not connected with the ending, or in other sense you can say it has no successor. So, this is a situation that this has no successor and this is not any way connected to the this one. So, how dangling can be avoided? Dangling can be avoided using the dummy activity, that is, you can just add one dummy activity with this and you can do something like this. So, this one we are calling as the basically dummy activity. So, whenever you have something like this, there is one node which has no successor, neither it is connected with the end node. In that case, using the dummy activity we can connect it, and for this dummy activity means effectively there is no activity between these two nodes, this node and this node, but to complete this one we are telling this. So, the time taken or the cost involved for the dummy activity will be 0. So, this is the second part which you are calling as. So, this is cycling, this is your dangling, and the third one is redundancy. What is redundancy? Unnecessary incorporating dummy activity in the network is called redundancy. That is, some dummy activity is not required at all, but you have unnecessarily given that dummy activity, that we call as the redundant activity. It is something like this. The redundancy can be shown like this. You have this one, 3 activities are there. So, basically this is your starting and this is your end, and there is one dummy activity you have assigned here from starting to end. So, here we say that the D, this D is the dummy activity or the unnecessary activity, and we call it as the redundant activity, because for these 3 nodes always there is a predecessor and successor beyond this one, because this is the ending node. So, this we call as redundant. So, whenever we are drawing the network, I have to avoid these 3 type of errors. One is cycling, another one is dangling, another one is redundancy. The next is how to construct a network. Some rules are there. To construct a network, basically rule 1 is each activity is represented uniquely by one and only one arc. That is, each activity, whenever you have the starting node and ending node, in between them there will be only one arc, that is, the flow only will be on one side, not more than one side. As I was drawing, the flow cannot be on both direction and like this. So, each activity is represented uniquely by one and only one arc. Rule number 2 is each activity must be identified to distinct end nodes. This again you have already seen in the figure, that there must have 2 distinct nodes from this 2 ends starting and ending. So, for each activity there must have distinct starting node, there must have distinct ending node. Number 3, to maintain the correct precedence relationship, basically whenever we are drawing, the following questions should be answered always. Number 1, what activity must immediately precede current activity? That is, what are for the current activity, before that what are the precedents or earlier activities are there, that answer has to be there before drawing the network. Number 2 is what activities must follow the current activity. So, the first one was what activity was there before the current activity, what activities are there just immediately after the current activity, and number 3, what activities must occur concurrently with current activity. That is, you are performing one activity concurrently, can any other activity can be performed or not. This we call as the concurrently this one. So, basically 3 things I have to think. One is what are the for a current activity, before that what activities are there, after that what activities are there, and number 3 is along with that what other activities can be executed. So, these 3 if you can answer, then easily you can draw the network. The numbering of events, or we call it as Fulkerson's rule. What is this? After the construction of each network, each event is assigned a unique number. Each event we are telling, we will see afterwards, each event is being assigned by a unique number Usually the number may be 0, maybe 1 or like this. We start with 0, 1, 2 something like this. So, if the numbering is done in such a way that it represents the flow of the network. That is, numbering means I want to say 1, 2, 3, 4 like this way. So, that from the number itself you can know which work or which activity has to be completed first and then which activity should occur and like this way. After that, the following rules should be used. Number 1, event number must be unique. It has to be there, it should be unique. You cannot copy, same number cannot be used in more than one place. Number 2, event numbering should be carried in sequence from left to right. Please note this one. When I was drawing, if you see, if you draw something like this, it has to be in the numbering should be from left to right. This is your left. So, if I make 1, this may be 2, this may be 3, then this may be 4 like this way. So, the numbering must be done from left to right on the increasing order 1, 2, 3, 4 something like this way. The next is the event numbers. Initial event which has all outgoing arrows is numbered least value 0 or 1. Usually we will start, you will see, with 1. The initial event from where we are going to the other events, the number of that event has to be 1 or 0. The head of an event arrow always bear the number higher than the one assigned at the tail of the arrow. Again, it is obvious, the number of the tail should be lower than the number of the head. That is, in the figure, if you see from 1 to 2, this is your head, this is your tail. So, the numbering of the tail must be lower than the numbering of the head, this we want to say. And the last point is, the gaps should be left in the sequence of event numbering to accommodate subsequent inclusion of activities if necessary. That means, we want to say some numbers may be left in between, so that if some activity is appearing afterwards, we can readjust it. That is, I want to say here, here you have made a numbering 2, 3 and 4. Suppose an activity has come over here. So, if I have given this number as say 6, then very easily I can mark it as 4 and then I can go like this. This is something like this way. So, some gaps whenever you are numbering, usually some gaps should be given. Whenever I am giving the gap, it is for the betterment of us, so that if some new activity is coming afterwards, then we can reallocate it. Otherwise, I have to make some numbering as something like A, B like this. Now, let us see, come to the next part, that is how to construct basically one activity, how to construct one network diagram. You just see study the problem very carefully. Let me read the problem carefully and after that only I will go through the diagram. Construct an arrow diagram comprising activities A, B, something C, D, E, F, I, J, K, L such that the following relations holds. Please note, A, B and C, the activities of the project can start simultaneously. That is, from the initial point, 3 activities A, B and C can be started simultaneously. Let me just read the problem first. Then I am telling A and B precede D. That is, before D starts, A and B must be completed. Similarly, B precedes E, F and H. That is, before completion of starting of E, F and H, B should completed. F and C precedes G. Then next one is E and H precedes I and J. The sixth one is C, D, F and J precede K and K precedes L. I, J, L are terminating activities. So, we have told what are which activities can be started simultaneously and what are the terminating. So, now let us start how to draw this one. The first activity you see A, B and C, the activities of the project can start simultaneously. So, let us start, this is your initial state. We have told A, B and C, the activities of the project can start simultaneously. So, this is your we are just drawing, let me draw and then I will just. So, these are the three activities, say this is A, this is B and this is C. So, the project was given to me, if you see the problem, A, B and C, the activities of the project can start simultaneously. So, we have drawn it, A, B and C can start, A, B and C has started, simultaneously they can work. So, basically start simultaneously means these three activities can be performed parallelly, not sequentially. Please make the difference. These activities can be performed parallelly. The point number 2 is A and B precedes D. That is, whenever you are performing the activity D, before starting of the activity D, their A and B must be completed. So, I am writing, say I am drawing here, suppose this is D. So, what was the point number 2? A and B precedes D. That is, before starting this D, this activity A and B should be completed. From here it is quite obvious that A has been completed, but from here I do not know whether B has been completed or not, and unless B has been completed I can't proceed to this, I cannot start this activity, this one. So, what I have to do? Once B is completed, here from B to A I can use one dummy activity, say D1. Please note this thing. If I use a dummy activity D1, then when I will start this activity D, I am ensured that the activity A and the activity B has been completed already. But if you do not use this dummy activity D1, you cannot say this thing. So, please again note this thing, that here I am using the dummy activity just to say that the activity B has been completed, because once activity B has been completed, I am putting one dummy activity from B to A, although it is not there. This is the use of the dummy activity. Let us see the point number 3. The point number 3, we are telling that B precedes E, F and H. That is, these three activities E, F and H, these three activities can start only after completion of B. So, this is say this one, this is your E. So, I am drawing this is your H. What about F now? So, E and H both will start after completion of this B. Let us see this one, there is another one, that is F. Now, F, if you see, F and C precedes G, we are telling, that is, before starting another one, that is G, G will come obviously later, but F also should be completed, and for this reason we are drawing from here to here, and this we are denoting as F at present. So, this is your F. So, once F is there, this F. So, point number 2, 3 has been completed, that is B precedes E, F and H. You see, E, F and H, these three can start only after B completes. That means, the B precedes this one. What is the next one? The next one is F and C precedes G. F and C precedes G, that is, there will be a node, and from C the activity G can be completed, can be started only after both F and C has been completed. So, I have drawn this, both F and C, once they are being completed, then only we are starting the activity G. So, this goes to your number 4. Number 5 is E and F, E and H precedes I and J. E and F precedes I and J, that is, there will be two activities, one is I, another one is J, and they must precedes your E and H. So, therefore, from E we are saying that one is J, another one is, we are saying it as activity I. So, what we have told that E and H precedes I and J, but one problem is there. What is the problem? The problem is this E and H, but H is here. So, therefore, again I have to use one dummy activity at this position, that is this one. This I am denoting as D2. So, once I am denoting this including one dummy activity D2. So, now you see E and H both precedes I and J, this is true now. So, this dummy activity is required now. So, using this dummy activity I can tell that E and H precedes I and J. The next one is C, D, F and J precede K. C, D, F and J precede K. So, this is your K, you see here. D is preceding, your J is preceding, your F, where is F? F is not preceding, C is not preceding. So, again what I have to do? To precede, to say that before starting activity K, C and F has been completed, again there must have one dummy activity between this node and this node. So, therefore, I will draw it something like this. Usually for cutting we use like this. So, say this is your node D3. So, once I am adding another node D3 over, I am sorry, this is wrong, this is absolutely wrong, this cannot be there. Before this is your J. So, it must be something like this. It has to be dummy activity is connected, should be there. So, this is your D3. So, this connecting from this to this, because this is not this, this is K. Before starting off this K, your say C and F should be completed. So, you are using one dummy activity J. And the last one is K precedes L, that is from here if you do it. So, K precedes L, this is not the last, and I, G and L are the terminating activities. So, you see I, G and L, these are the terminating activities. I think it is clear now to you that how we are completing the activities or how you are drawing the network over here. So, here if you see, depending upon the problem given to you, whenever the problem is given to you, you try to find out which precedes what or which succeeding what, and what is the starting node, what is the ending node, and from there you can draw like this way. We will see afterwards also when we are solving the problem by critical path method. Just see quickly tips for drawing the network. Number 1, try to avoid arrows which cross each other. If possible, always try to follow it. Try to avoid arrows which cross each other. Use straight lines to denote the arrows. Do not try to represent an activity by its arrow length. Please note this one. Represent an activity by its arrow length. Number 4, make direction of all arrows same, that is whether it is left to right or right to left, make only in one direction. Use dummies as many as you want in rough diagram. Please note this, use dummies as many as you want in rough diagram, but final network must not contain redundant dummy activity. Be rest assured that you should not use any redundant dummy activity in your final network diagram, because the costing will be much more. So, you have to note this one. And the last point is network must have only one initial node and only one final node, that is there must have only one starting point and there must have one ending point. So, if you follow the tips, I think you can draw the diagrams, network diagram very easily. In the next class, we will see after drawing this network diagram how to find out the critical path or the project cost using the CPM method and then the PERT method. Thank you.